That is, if two diodes are connected back to back, then what will be the voltage across V1 and V2? Let me say this, if this voltage V at the diode V1, the plus minus let us do first and write for plus minus for V1, V2 and for the battery. For the battery, plus will be at the larger side and smaller is minus. The four options are given: 3 volt, 2 volt, 2 volt and 3 volt.
Participants, do you have any doubt
And
in last class, last session?
and then you have to write P and N and P. According to that, we can decide which diode will be forward biased and which diode will be reverse biased. First, let me all of you just write down which diode is forward biased, which is reverse biased. D1 is forward biased, and D2 will be D-pot will be for the D2. D2 will be reverse bias. Correct. So D1 is forward biased and D2 is reverse biased. Okay. So for D1 we can say that D1 as it is forward biased, therefore it can be replaced by short circuit. So therefore V1 is equal to 0 volt. And D2 as it is the reverse biased diode. So the reverse biased diode, because the P is connected to negative and N is connected to positive, therefore this is reverse bias. As it is reverse bias, it can be replaced by open circuited diode. And open circuit diode, the voltage will be equal to the voltage applied. Therefore V2 will be equal to 5 volt. So we can say that there is no option which is equal to these things. What we can say approximately the answer number 4 is correct, because the V1 is given as 0.018 when V2 is given as 4.98, which is nearer to this. It is nearest to our answer. But the question is how to get this, the exact value in our answer. So to get the exact value, we have to use the Shockley equation or diode current equation that we have seen in earlier videos. I will make the circuit again for our reference here, and now the circuit we already know that in this circuit these two diodes D1 and D2 are connected in series, and V1 and V2 are taken from left to right. Plus minus symbol is given like this, and for the battery also large size is plus and small is minus. Diode current ID is given as ID equal to I naught e to the power V upon eta Bt minus 1. This is the diode current equation, where ID is the current flowing through the diode, I naught is the reverse saturation current, V is the applied voltage, eta is the ideality factor, Vt is the thermal voltage, and 1. And current is flowing from left to right, diode D1 and D2. The same current will flow from both of the devices D1 and D2 as they are connected in series. As D2 is reverse bias, therefore the current flowing through D2 will be restricted to reverse saturation current. The reverse saturation current I naught. As both of the devices diode D1 and D2 are made from same material, therefore the reverse saturation current from D1 and D2 will be same. Therefore ID1 will be equal to I naught only. As ID1 is equal to I naught, therefore the equation becomes as I naught equal to, in place of ID we can place I naught. So, this equation will be equal to I naught e to the power V1 is the voltage applied across the diode D1, V1 upon eta Vt minus 1. Or we can write, we know that the ideality factor eta is equal to 1 for silicon diode. Therefore, I naught will be equal to I naught e to the power V1 upon Vt minus 1, or I can say eta will be equal to 1, or we can separate it for I naught, and dividing by I naught, the equation will become 1 equal to e to the power V1 upon Vt should be this should be V1 actually, by mistake it is written V. So, this is V1 upon Vt minus 1, and this again by changing from left hand side to right hand side, this will become E upon V1 upon Vt equal to 2. Taking natural log both side, we can write V1 upon Vt equal to natural log of 2, or V1 equal to V1 equal to Vt natural log 2, the value of natural log 2 is equal to 0.6931 and value of Vt 0.026, very nice. So, we can multiply 0.026 with the value of natural log 2, that is 0.6931, the value comes 0.018. This is the actual value of the voltage across D1. Now, we have to calculate value of the voltage across D2, that is equal to 5, will be equal to the total voltage 5 volt minus V1. So, 5 volt minus 0.018 volt, this becomes 4.98 volt. Okay, so now we have got the value of the voltage across diode D1 as 0.018 volt and at the diode D2 4.98 volt. This is the answer. Thanks for watching.